Bismillahirrahmanirrahim. So, okay. So we will start from here, from this equation. Okay. Now, in this equation, if you see, there is a temperature. I will zoom it a little so that it is easier for you to look at. Okay. Now, you can see that this is theta. Theta is the temperature that is unknown. We want to know what is the temperature now. Okay. So, we already discussed about thermometric property. If you remember, thermometric property is that property, uh, which will respond to the change of temperature. If you change the temperature, the thermometric property will change. If any property does not respond to the change of temperature, then that is not a thermometric property. Now, several thermometric property we understood in the last class, that is resistance, length, area, volume. These are the properties which vary with the variation of temperature. So later here you can see x theta, x0, x actually not 0, this is x ice, and x steam minus x ice. What are all these? I will explain it now. Can you see the board? Let me stop this sharing for a little bit amount of time so that you can see the board. Okay, so I will explain it here. Take a look. Okay, so as I was saying, I want to know the temperature theta. From here I will deduct or subtract the lower fixed point of degree Celsius divided by the upper fixed point minus the lower fixed point. Okay, is equal to, can you tell me what will be here? The corresponding value of thermometric property for each temperature. What does that mean? Let us say I have taken resistance thermometer. So with temperature, what will vary? The resistance will vary. Now at theta degree Celsius, let us say the value of resistance is R theta. So I have subtracted 0 degree Celsius, right? So here it will be R ice, because the 0 degree Celsius temperature is also known as ice point. Why? Because if you start reducing the temperature at 0 degree Celsius, the water will start to convert to ice, right? So we can say that this is the resistance at 0 degree Celsius, which is known as R ice. This is not rice, R ice. Ice is as subscript. Okay. And here 100 degrees Celsius, this is the steam point. Why? Because if you apply heat to water, it will start converting to heat at 100 degrees Celsius temperature. At that temperature, the resistance is R steam. And minus here what we have, 0 degrees Celsius. So I will write again R ice. Okay. So now in this particular case, we have resistance thermometer. That is why I have taken R. But what if I have taken another thermometer? Okay, so the thermometer property will change that time. So to represent the common thermometric property, they have represented this one by X. Okay, now if you have taken resistance thermometer, what will happen? This X will be replaced by R. If you have taken length thermometer, like mercury thermometer, the length will change, the height of the mercury level will change, right? So at that time you might write L theta, L ice. So X is common for all. Okay, got the point? Understood how this equation came? This is kind of similar to a calculation that we saw during the calculation of humidity, relative humidity. If you remember, it is similar to that, right? Anybody has any doubt? Bolo.
Sir, এখানে theta value দিয়ে কি represent করে?
Theta is the temperature. Theta is the temperature.
কিসের?
We know a particular value. Okay, we know what is the resistance at this temperature. We know the resistance at ice point. We know the resistance at steam point. If all these informations are available, then I can find out what is the temperature now. Okay, from this value I can easily find out the current temperature. কি বলছি বুঝতে পারছো? যেমন মার্কিউরি থার্মোমিটার যেটা আমরা নরমালি ইউজ করি, এটা যখন একটা সার্টেন লেভেলে উঠে যায়, কতটুকু উঠছে সেটা দেখে আমরা বলতে পারি যে এখন টেম্পারেচারটা কত। তার মানে লেংথ আগে কত ছিল, 0 ডিগ্রিতে লেংথ, এই ইকুয়েশনটা ইউজ করে আসলে যে কোনো টেম্পারেচার বের করা যায়। দিস ইজ usually it is used to find out the temperature, but sometimes it is used to find out the value of the thermometric property at a particular temperature. How? Let us say I give you the temperature. Now I want to know at this temperature what is the value of this thermometric property. So you know all other value, only x theta is unknown, you can easily do that. Now this will be more clarified when you solve a numerical example. Okay. Now let us check the book and see if, okay, before going to the book, if you have any question over here, you can ask. This is very easy to understand if you think about the corresponding values. For theta, there will be x theta. For 0 degree, there will be x0. Now x0 is basically x ice, okay, because that is the ice point. And 100 degrees Celsius, for this one, the corresponding value is x steam. Okay, so if you just put the corresponding value, this equation is nothing difficult to understand. So anybody wants to ask any question before I move to the book?
স্যার,
হ্যাঁ বলো।
স্টিম এন্ড আইস এগুলা কি চেঞ্জ হয় নাকি এগুলা সব সময় 0 ডিগ্রি 100 ডিগ্রি থাকে?
For Celsius scale, it is 0 degree and 100 degree. But let us say you are calculating using Fahrenheit scale. So at that time, what will happen? You will put the value of lower fixed point and upper fixed point for Fahrenheit scale. This one we discussed in the last class, if you remember. The lower fixed point for Fahrenheit scale, it is 32 degree Fahrenheit, and the upper fixed point of Fahrenheit scale is 212 degree Fahrenheit. And for Kelvin, it is 273 Kelvin and 373 Kelvin, the lower fixed point and upper fixed point respectively. Okay, so it depends on which temperature scale you are using. Here I am using degree Celsius, so I have put the lower and upper fixed point in degree Celsius value. Okay, for that scale. Clear, Irfan?
স্যার, ক্লিয়ার ক্লিয়ার।
Okay, and also you should have remembered or kept it in your mind. I told you that whenever we are expressing temperature by theta, I am using the Celsius scale. But if I am expressing the temperature by capital T, then I am using the temperature in Kelvin scale. Okay, and Fahrenheit, this is not generally used. Okay, so let me share this screen with you again. Okay, so from here they have actually simplified the equation. You see, 100 minus 0 will give us 100 at the denominator. Okay, theta minus 0 will give me theta only, so here it will be theta by 100. And if I want to find out this theta, I have to change the side of this 100, and as this is in the denominator, if I change the side, it will be multiplied. It is divided here, so if I change the side, it will be multiplied. Okay, so this is just as it is into 100. So using this equation, we can easily find out the temperature. Okay, to calibrate thermometer in Celsius.
Sir?
Yes.
Theta ki relative humidity?
Theta, the temperature in Celsius scale. Theta is the temperature in Celsius scale. Our target is to calculate the temperature. This equation is kind of similar to a calculation that we used to do while calculating the relative humidity. It is similar, but not that actually.
Okay, sir.
Okay. Now, moving on. So Fahrenheit scale, let us try to know a little bit about this. The scale was introduced in 1714 by German scientist G.D. Fahrenheit. Okay. Now you people are quite lucky actually, because nowadays I do not see the birth year and death year of this scientist to be appearing in the exam. But during our time, this used to be very important. Okay. So, but I find it this very actually unnecessary, because when Fahrenheit was born and when he died, why is it important? What he did throughout his life, that is important, that we should know. Correct or not? What is the purpose of wasting our memory by memorizing this birth year, birth date, and everything and all? Acha, okay. At that time, the lowest temperature known to the scientist was the temperature of mixture of equal amount of ice and ammonium chloride. Now we know the lowest imaginable temperature now is the temperature at which the volume becomes zero. That is minus 273 degrees Celsius. If you remember from the Charles law, we saw a graph, right? When we increase the line backward, it intersects x-axis at minus 273 degrees Celsius, right? So that is the lowest imaginable temperature. But at that time, at the time of these scientists Fahrenheit, they used to think that the lowest temperature known is the temperature of the mixture of equal amount of ice and ammonium chloride, whose temperature was less than melting ice. And this temperature was less than melting ice, that is 0 degrees Celsius, less than 0 degree. Fahrenheit considered this temperature as zero and its steam point is the upper fixed point. Yes, we know this one. Melting ice is the zero and steam point is the upper fixed point. He divided the fundamental interval between these two points into 212 equal division. See, this is the case. Okay, so that is why the upper fixed point is 212 degrees Celsius for Fahrenheit scale. Nobody is responding. Everyone is sleeping. Somebody should respond.
Yeah.
Right? Okay. So equal division and called each division 1 degree Fahrenheit. Okay. So the upper fixed point in the Fahrenheit scale is 212 degree Fahrenheit and the temperature of ice point found to be 32 degree Fahrenheit. Yes, we know that this is the lower fixed point in Fahrenheit scale, right? At this temperature, what will happen? The ice will melt or the water will convert to ice depending on whether you are giving heat or taking out heat. Okay. Achha, so the lower fixed point in Fahrenheit scale is taken to be 32 degree Fahrenheit. According to this calculation, the 100 division of Celsius or Kelvin scale is equal to 180 division of the Fahrenheit scale. Now, why it is like that? If you check the Celsius scale, the lower fixed point is 0, the upper fixed point is 100. So the division between them, or the difference between them is 100. But if you take a look at Fahrenheit scale, the lower fixed point is 32, upper fixed point is 212. The difference between them is 180. So this 180 is equivalent to the 100 division of Celsius scale. Now the similar thing we can say for Kelvin scale also. In Kelvin, 273 is the lowest, sorry, not the lowest, the lower fixed point and upper fixed point is 373. So 273 and 373, the difference is 100. This 100 is equivalent to 180 difference of Fahrenheit scale. Okay. I hope this is clear. If anybody have any doubt, then kindly share it now. As I cannot see your hand raising, so please unmute yourself and talk. Speak up.
Sir, clear.
Clear? Okay, fine. Great. So let us go through the definition. The scale in which the ice point and steam point. See the ice point. That is what I was talking about a little bit ago. And steam point. I hope you already understood. So ice point is 32 degrees Celsius and steam point it is 212. Now this word is important. Respectively. Now respectively means I have mentioned ice point first. Then the temperature that I have mentioned first will be the corresponding one. And steam point I have mentioned later. So the later one will be corresponding to the steam point. And the fundamental interval is divided into 180 equal division. This is 212 minus 32. That will give you 180 equal division. This is known as Fahrenheit scale and each division is called 1 degree Fahrenheit. Correct. Okay. Now since the Fahrenheit scale, theta ice, that is the ice point, is 32 degree and theta steam minus theta ice. Therefore 212 minus 32, it will give me 180 degree Fahrenheit. So for the Fahrenheit scale, the equation 1.1, do you understand which one is equation 1.1? This one. This equation will become theta minus 0 degree Celsius will become for Fahrenheit scale, it will be 32 degree Fahrenheit. It's page number 4. তুমি এতক্ষণ ধরে জিজ্ঞেস করতেছো পেজ নাম্বার কত? তুমি আমি স্ক্রিন শেয়ার দিছি তো তুমি কি করছো? চার্জ নাই। Okay. 4 number page. Okay. So you can see 0 degree Celsius has become 32 degree Fahrenheit, and the difference between upper fixed point and lower fixed point, it is 180. Instead of this, you could have written 212 minus 32. That would have given you the same value, right? And the right hand side, it is just the same. X theta minus x size, x16 minus x size. So then if you change, if you want to get the value of theta, at first you need to multiply 180 degree here, right? Because this is divided, if you change the value, it will be multiplied, and this 32 is minus in subtraction. So if you change the side, it will become addition. Okay. So if anybody have any doubt till equation 1.3, kindly let me know. These are very easy things to understand. Only if I could have taken, class in person in a school, I could have accelerated a little more, because these things are very easy and we can, speed up a little. Okay, so let us go through now mercury thermometer. Now in mercury thermometer, in case of mercury thermometer, the thermometric property x is the length. That is what I was talking about. In the mercury thermometer is the thermometer that we use in our daily life. Okay, so what happens when the bulb of the thermometer comes into contact with our body? If our body is at higher temperature than the normal one, then what will happen? Heat will be transferred from my body to the thermometer, and as a result, the mercury inside the thermometer will be heated, and the thermometric property is length. So as a result, the length will respond to the increased temperature by increasing in length, right? Yeah. So you, by seeing the increasing length, you can say that yes, I am having a fever or not. Okay, so this is the thermometric property, that is length. So they are saying about capillary tube. We already know what capillary tube is. Capillary tube is a very narrow tube, right? Why it has to be narrow? Because the more narrow the tube is, the more noticeable the rise of the liquid will be. Do you understand my point? Let us think about ocean. If I add 1 bucket of water in the ocean, will you notice any difference in change in height? No change in height will be noticed. Even if you pour 100 buckets of water, no height difference will be noticed, because it is wide, it is not narrow. But now let us say I have taken a very narrow tube. Here if I pour even just bottle ঢাকনাকে কি বলে, cap. Okay, 1 cap amount of water in the tube, what will happen? You will see a noticeable change in the height, right? So that is why you have to use a capillary tube, or else you won't notice the change. Acha. So kindly go through these things. Okay, efficiency we already know, right? Okay. Then refrigerator. Somebody say, is this the next page?
স্যার অন্য পেজে চলে গেছেন।
ওই হই, কোথায় পেজ 4 এ ছিলাম, পেজ 4 থেকে 29 এ চলে গেছি। ভাই সব তোমরা একটু আমাকে পেজ 5 টা খুঁজে পাইতে সাহায্য করো। এটা পেজ নাম্বার 9, এটা 11। স্টুডেন্ট
স্যার অনেক নিচে যান।
26 এর দিকে।
26
ও সামারিতে চলে আসলাম। তোমরা সবাই প্লিজ বইটা একটু কালেক্ট করে ফেলিও, ঠিক আছে? তাইলে আমিও কালেক্ট করে ফেললে বইটা থেকে পড়াইতে একটু ইজি হবে। আবার পেজ 3। Hmm. 16। একদম নিচে নাকি? তাহলে আমি একদম নিচে চলে যাই। 36 এ চলে আসলাম।
26 এ স্যার।
26। ও আচ্ছা, আমি বোধহয় নিচে যদি এখানে লিখি 26, তাহলে বোধহয় তাড়াতাড়ি চলে আসবে নাকি না? 26 এই তো মিল গয়া। कोई मिल गया देखो. So for mercury thermometer, the thermometric property is L, that is length. So X has been replaced by L. L theta minus L is L100 minus L is. The writing is not clear, but we can understand what is written here, right? And for resistance thermometer, it will be R. Clinical thermometer is the one that we use, okay? That is the mercury thermometer, okay? And it is calibrated
Sir.
in scale. হ্যাঁ বলো.
মার্কিউরি থার্মোমিটারটা একবার বলবেন, আমি ভুলে গেছি।
মার্কারি থার্মোমিটার হচ্ছে যে ক্লিনিক্যাল থার্মোমিটার যেটা কিনা আমরা নরমাল লাইফে ইউজ করি। এটাকে মার্কারি থার্মোমিটার কেন বলা হয়? বিকজ দ্য লিকুইড দ্যাট ইজ ইনসাইড used inside the thermometer is mercury. Okay, and the thermometric property of mercury is length. That means whenever you change the temperature, the length of the mercury changes. Okay, if you decrease the temperature,
Okay, sir.
the length will decrease. If you increase the temperature, the length will increase. So length is the property that responds to the change of temperature, and hence it is thermometric property. Acha, I have another class with you today, right?
Yes, sir.
Okay, so we will continue inshallah. We have less than 10 minutes for this session. So as soon as we finish this session, I will start another meeting and we will continue inshallah. Okay. Acha, I'm a little bit thirsty actually. So let me drink a glass of water, and so I will end the meeting here and I will give another meeting just after 2-3 minutes later. So join again. Okay. And you can also have a glass of water, or if you are hungry.
স্যার এক মিনিট
হ্যাঁ বলো.
স্যার আপনি আমাদেরকে বললেন না ওয়েব চ্যাপ্টারে কি জানি ডাউট ওগুলা প্রিন্সিপালের সাথে ডিসকাস করবেন।
ওয়েভের সবগুলা ক্রিয়েটিভ কি তোমাদের শেষ হয়ে গেছে?
না,
হ্যাঁ ঠিক আছে, কি বলছ?
সেশনে তো 20